Hello, welcome to Lecture 7 Coordinate Geometry. This is based on Chapter 7 of Mathematics for Class 10 and based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. I would request students to go to my Class 9 Maths lecture. This is lecture number 12, Coordinate Geometry, and this will help you in understanding this chapter much better. But I will try to anyway to make it a complete. I will try to review what I had taught in Class 9 lecture 12 Maths on coordinate geometry. So as I say, see my channel playlist for class 9 lecture 12. So please go through it. It will be beneficial for you. So there I had talked about linear equation in two variables. That is x and y are the variables. And this is the equation of a line. Say y is equal to mx plus c. This is a line. When x is equal to 0, then y is equal to c. This is the y-intercept at c. This is the value of c. And the slope of a line, or it's called the gradient, is given as y2 minus y1 divided by x2 minus x1. So that is the slope. Okay. The change in y divided by change in x is the meaning of slope. And also I have told distance between any 2 points in Cartesian coordinates. Suppose these are the 2 points, say A and B. Here A and B. The distance is nothing but square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This is almost like a Pythagoras theorem. That is, this d square is equal to a square plus b square. That is, the hypotenuse square is the base square plus the height square of a right angle triangle. Then also I had discussed linear equation in two variables. That is, if you have two equation of line and if they intersect, then this 2, 3, this point obeys this equation of line, that is this red line and the blue line. Okay, if they intersect. But if suppose the lines are parallel, then you will not have any point which will obey both the equation of line. I had also shown that if suppose you have two linear equation, then it should obey simultaneously. That is, suppose here this you take 4x minus 6y and this equation of line is 2x plus 2y. So what I do is, this is 2x plus 2y is equal to 6. This one I multiply by 2. I get 4x plus 4y is equal to 12. The 6 into 2 is 12. 2 into 2 is 4. So now I can, and I write this 4x minus 6y. So I can subtract this 4x. So I get 4x minus of minus 6y is 10y and 12 minus 12 is 0. So y is equal to 0 and similarly y is 0. You substitute y is equal to 0 in any one of this. If y is 0, then x is equal to 3. So this is discussed in class 9 and I will request you all to go through my lecture 12 of class 9 maths. So now let us discuss some example and some exercise. Example, find a relation between x and y such that point xy is equidistant from point 7, 1 and 3, 5. This is 3, 5, this point, and 7, 1. So middle point is of course equidistant and all this line will be equidistant. This is perpendicular. Okay, we can show it is perpendicular and all these points will also be equidistant. Any point you take it, this point from here to here will be same. So what we have to do is we have to find the equation of this line. Okay. So how do we get this equation of line? Here let P of xy be equidistant, any point equidistant from this A and B such that any point P, AP is equal to BP. This you should remember and think about Pythagoras theorem. D square is A square plus B square. Okay, for a right angle triangle. So now I can write x minus 7 the whole square plus y minus 1 the whole square is equal to, this is distance AP, is equal to, I said should be equal to BP. Okay, here I have written. So x minus 3 the whole square plus y minus 5 the whole square. So I have equated it here. I expand this. So this is very simple. You have this minus 14x, this minus 6x, you bring it here. And similarly with this y square will get cancelled. This minus 10y also you bring it here, and this minus 2y plus 10y when you bring from right hand side to left hand side, and this minus 6s will become plus 6s. So you just do this simple algebra and you will get x minus y is equal to 2. So this is the equation of y is equal to x minus 2. Now exercise 7.1. Find the distance between the following pair of points. So this is very easy. I will not do all this. This formula you know. So suppose A, this is B. So this is x1, y1, x2, y2. Just substitute here and you will get it. It is very trivial. I will not waste time here. Similarly, this find the distance between, okay. So this also 36 square plus 15 square, this is 0. Square root of this number will be the distance between this point A and point B. So I will not do all this. These are very trivial and this was elaborately discussed in class 9. Exercise 3, determine if the point this A, B, C are collinear. So it will be collinear if suppose this is A and this is C. AB plus BC is equal to AC, then of course it's a straight line. So it is a collinear. Or I will show in the next few slides that you can find the area of a triangle from this coordinate. If the area of triangle is 0, that means they lie on the same line. Okay, it's obviously. And this is obvious because for any given triangle, the third point has to be non-collinear. Okay. And to construct a triangle, you have to have minimum 3 points. Now 4, check whether A, B, C, these are the points given here, the coordinates, are vertices of an isosceles triangle. So what do you mean by isosceles triangle? That means two sides have equal length. So you find the distance between AB, BC and AC, and if any these are equal, AB is equal to BC or AB is equal to AC, then of course two sides are equal means they are isosceles triangle. Okay, that you do it. I'm not going to do here. Use this formula. Whenever you have to measure distance or you have to calculate the distance, use this formula. Exercise 5. In a classroom, 4 friends are seated at a point A, B, C and D as shown in figure 7.8 of your book. Champa and Chameli walks into the class, and after observing for a few minutes, Champa asks Chameli, "Don't you think ABCD is a square?" Chameli disagrees. Using distance formula, find which of them is correct. Either Chameli is correct or Champa is correct. You have to find whether it is square or not. And since you know from the definition of a square that this distance AB, BC, DC and AD should be same, and the diagonal also should be same. If they are same, this BD and AC are same, then of course it is a square. And if it is a rhombus, then your diagonals are not equal. The rhombus can be tapered one. Okay, your two diagonals may not be equal, so then it is not a square. So I will not go into detail how to find this distance. Now you know it. You find this AB, BC and CD and also this distance. That is very easy to know from the earlier formula. Okay. Name the type of quadrilateral formed if any by the following points and give reason for your answer. A, B, C, D are the 4 points. Okay. So these are the 4 points. So these are all equal. As this one, you can find it out. And so it is a square. It's very simple. Maybe it is too simple for you all, but anyway, for sake of completeness, we will do it. Second one, these are the coordinates. Okay. And if you see from here, you will find that AB is equal to AC plus CB. This A, B and C. You do it and you will find it is collinear and not a quadrilateral. So this is not a quadrilateral. So it is asking name the type of quadrilateral. This is square is a quadrilateral, but this is not quadrilateral because they are collinear, and quadrilateral means all the 4 points have to be non-collinear. Third, these are the points, and here I see that AB is equal to CD and BC is equal to AD, but your diagonals may not be same. Just check it. And so if these are same, then it is a parallelogram. Okay. Exercise 7. Find the point on the x-axis Px, 0, which is equidistant from A and B. Very similar to what we had done. So you find the distance between PA and PB. PA is equal to PB. So what is the value of this x? Because he's saying it is equal. I know it is equal. So I expand this and I get this one, and you move all the x in one side and all the numbers in the right hand side. So you will get x is equal to -1. Just go through it. You should always freeze it, pause it, and just if it is too fast, you should read and you will able to understand. So your coordinate x is equal to -7 means the coordinate will be -7, 0. Okay. Here is the question. X, 0 is an equidistance from point A and B. Now exercise 8. Find the value of y for which distance between 2 points P and Q is 10 units. So this is also very easy. You use the formula, the coordinate formula for distance. D square is equal to x2 minus x1, that is 10 minus 2, the whole square, plus y2, this is y, minus of -3 become +3, y plus 3 the whole square. So now you expand this, you get this, and now you get this polynomial. Now I can factorize it. This has been dealt in detail in class 9. So please go through my class 9 lecture on factorization. So here I have factorized this y is common, y minus 3. Here I have taken 9 common, 9 times y is 9y, 9 into 3 is 27. So minus 27. Now this y minus 3 is a common factor here and here. So y minus 3 into y plus 9 is equal to 0 means either y minus 3 is 0, that means y is equal to 3, or y plus 9 is equal to 0, that is y is equal to -1. So please go through my 9th standard lecture. I am purposely not writing full here so that you should go back to the 9th standard class and learn how to solve this kind of a problem. Exercise 9. If Q is equidistant from this point P and R, find the value of x, okay, this value. Also find the distance QR and PR, okay. Q is the point equidistance from P and R, okay. So this is also very similar. I will not go much in detail. Here it is given, okay. This is 5 minus 0, then minus 3 minus 1. This is QP and equal to RQ is here, okay. X minus 0 is x square plus 6 minus 1. So you again expand it and you will get x is equal to plus or minus 4. Now 10, find the relation between x and y such that point xy is equidistant from point. These are all very similar. So I am repeating again and again. So here again you see same thing. Xy is equidistant from this. So I write 3 minus x plus 6 minus y the whole square. And then for this also I equate it here, minus 3 minus x and 4 minus y the whole square. And you again expand it and you will get, this is the equation of line. So you will have one full equation on all point will satisfy this equality, okay. So if this point is P and this is QR, then PQ is equal to PR, okay. You can show it. Now section formula. So what is this section formula? That is, if you have a line here AB, then point P divides this line AB in the ratio of M1 is to M2. So if you are given, say, at what ratio it is dividing, how do you find the point P, the coordinate of point P? Here the formula is, says P xy divides the line segment joining A and B. X1 y1 is A and B is x2 y2 internally in the ratio of m1 is to m2, what I said. Then how do you find this P of x comma y? I have drawn some perpendicular line and here these are horizontal parallel to x-axis. So I made two triangles, and since this angle are same, these two triangles are similar. So here I have written triangle PAQ is similar to triangle BPC. So these are two similar triangles. And then from the similarity condition, corresponding part of similar triangle. So AP by PB, these are the hypotenuse diagonals, is equal to AQ by PC, and that is equal to PQ by BC. So I know that AP by PB is, AP is M1, this is M2, and AQ is your X, this is the point X, so this will be all X here, okay. So x minus x1, and PC is this one, that will be x2 minus x, what I have written here. And this PQ is, this is a PQ. So this point is y minus y1 is here, this PQ. And this BC is y2 minus y. So now I get this relation. So from there I take x, first I take x, this equality sign I first take, and I write here m1 into x2 minus x1 is m2 into x minus x1. Just expand it and you will get x is equal to this. So similarly I equate m1 by m2 with y, and I will get m1 y2 plus m2 y1 divided by m1 plus m2. So this x is this x and this y is this y. So I can now know, given me m1, m2, x1, x2, I can find what is the point, okay. So given me coordinate and the ratios, I can find this value. So this will be very useful in next few exercises. We will do this. And so I write this P x comma y is equal to x is this value and y is this here. Okay, now a special case. The midpoint of a line segment divides the line segment in the ratio of 1:1. That is, dividing in equal ratios. Therefore, the coordinate of the midpoint P of the points A and B is x1 plus x2 divided by 2, comma y1 plus y2 divided by. This is very easy to show. This is our formula. Okay, when m1 and m2 are 1, so m1 1 plus 1 is 2, this is 1, so x1 plus x2, and this will be your m1 and m2 are 1, so y2 plus y1 by 2. That is, if you have to divide this 2 point into equal ratios, so it is x1 plus x2 by 2 and y1 plus y2 by 2. Example 6, find the coordinate of the point which divides the line segment joining the points this and this in the ratio of 3:1 internally. So I can use this formula. Okay. So let us say P is that point and we have to find this x and y. So I use this formula, that is m1 is 3. So 3 into x2 is 8. So m1 into x2 plus m2. m2 is your 1 into x1. x1 is, this is your x1. This is x1, this is y1, this is x2, this is y2. So use this formula and you will get 7, 3. So the point P will be 7, 3, which will divide the line in the ratio 3:1. Okay, example 7. In what ratio does the point P, this is the x and y of the point P, divides the line segment joining point A, this is the coordinate of A, and B, this is the coordinate of B. So I use same formula. So this P of xy, this is P of xy is given here. And I know M1 and M2 I have to find. And x1, x2s are given here. This is x1, this is x2, this is y1, this is y2. And M1, M2 I have to. So I can equate this 4 with this, minus 4 with this, and 6 with this. Okay, so what I do here is same thing. Let minus 4 comma 6 divide AB internally in the ratio M1 by M2. Using the section formula we get minus 4 comma 6, this is minus 4 comma 6 is equal to, I use this formula and I get, this is, I write M1 plus M2 is equal to some constant C. So I use this one equal to minus 4. So what I get here is 3m1 minus 6m2 is equal to minus 4 times m1 plus m2. So minus 4 times c. And also I get this one is equal to this, that is minus 8m1 plus 10m2 is equal to 6 times m1 plus m2. m1 plus m2 is c. Now since I have to find m1 and m2, I get rid of this c by multiplying 4 into 3 is 12 and 6 into 2 is also 12. So I write it here. So this is minus 12c, this is plus 12c. If I add it, it goes to 0. So 20 minus 18 is 2 and minus 16 plus 9 is. So I get the ratio 7m1 is equal to 2m2. So m1 by m2 is 2 by 7. So I get this ratio. So in what ratio does the point P? This point P divides this line AB in the ratio of 2 by 7. Or most simpler way is just compare both x and y coordinate to get m1, m2. So here you see I have just compared this 3m1 minus 6m2 is equal to minus 4 and then I just rearrange it, I get the same. Similarly, you compare this with 6, you will again get m1 by m2 is 7 by 2. Okay, now example 8. Find the coordinates of the point of trisection, that is point dividing in 3 equal parts of the line segment joining A and B. So this is the line A and B and you divide into 3 equal parts. So this is part 1, this 2 and this is 3. So I call this point as P and this point as Q. And we have been asked to find the coordinate of point P and Q. So how do you find the coordinate of point P and Q? I use the section formula. So here it is, let P and Q be the point of trisection of AB, that is AP is equal to PQ is equal to QB, and use section formula. And what is the section formula? So I use for this point P, this line AV is divided by P in the ratio of 1:2. So this is M1, this is M2. So I use this section formula, very easy, go back and check it. And you will get minus 1 comma 0 for this P. Similarly, I use AB, this now will become 2 and this is 1. So M1 is now 2. Here M1 was 1. Okay, M1 into X2. X2 was this. So here also it is, your now M1 is 2 and this is your X2. So similar formula, only this 1 and 2 will get replaced here because now it is cutting in the ratio of 2:1. So you get this coordinate. So this is a coordinate for P and this is a coordinate for example 10. If point A, B, C and D, here it is P is not given, are the vertices of a parallelogram, then find the value of P. So I can know the value of P by, suppose I know this is bisecting this parallelogram. So this point I can, this each line is dividing in the ratio of 1:1. This is also 1:1. So what I do is I equate it, this midpoint, and for each case M1 and M2 is equal to 1. For this also M1, M2 both are 1. This is say M1, this is M2, that is also 1. So I use this earlier section formula and I equate it. So this is a center point for line, midpoint of AC. Okay, this AC is 6 plus 9 by 2. This is a midpoint. As I said, if it is 1:1, 6 plus 9 by 2 and 1 plus 4 by 2. This is the midpoint of AC. And again, similarly, the midpoint of BD will be this B and D. 8 plus P by 2, comma, the y will be 2 plus 3 by 2. So this is your 5 by 2. 1 plus 4 is 5, 2 plus 3, 5 by 2. And so this has to be also equal. So you just equate this, 8 plus P by 2 is equal to 6 plus 9 by 2. So you can get P is equal to 7. So this value of P will be 7. Now exercise 7.2. First one, find the coordinates of point P which divides the join of this A and B. This P divides in the ratio of 2:3. So this is again simple. Okay, use M1 is 2. So you put M1 as 2. X2 is your, this one is X2. So you just substitute and find the value of. Now second, find the coordinates of the points of trisection of line segment, this and this. This same like what we did in the last exercise. So please is the same thing, only the number changes. Third, to conduct sports day activities in your rectangular shaped school ground ABCD. This is your ABCD. This is your ground. Lines have been drawn with chalk powder. These are the lines are drawn with chalk powder at a distance of 1 meter each. Each distance is 1 meter. So you have about 10. This is B, up to B is 11 meters. 100 flower pots have been placed at a distance of 1 meter from each other. Okay. So 1, 2, like this 100 meters, that means 100 flower pots have been placed at a distance of 1 meter from each other along AD. This is along AD as shown in figure. Niharika runs 1/4 the distance AD on the second line and post a green flag. So how much she runs? Quarter the distance of AD, that is 100 meter. That means quarter of 100 meters, 25 meter in the y-axis, and each is in the second line means this 2 meters. So this is the coordinate of Niharika, and Preet runs 1/5 the distance of AD. That means AD is 100 meters. So this is 20 meter in the y direction on the 8th line and posts a red flag. So she posts, this is the 8th line. So this is the coordinate of Preet, 8 meter, comma 20 meter. This is x-axis, this is y-axis. What is the distance between both the flags? So what is the distance between both the, you have given a coordinate, so it is easy to find. Now d square is equal to, you do x2 minus x1 the whole square plus y2 minus y1 the whole square and take a square root of it. You will get the distance. So further, if Reshmi has to post a blue flag exactly halfway between the line segment joining the two flags, where should she post the flag? So this is very simple. 8 plus 2 divided by 2 and 20 plus 25 divided by. So in middle you have to. So that is the middle point of the two flags. Fourth, find the ratio in which the line segment joining, this is say point A and this is B, is divided by say point P. So you have to find the ratio. It's again very simple. You use that formula of the section, that is you equate m1 into x2 plus m2 into x1 divided by m1 plus m2 equal to minus 1. So you will get the ratios of m1 and m2, and similarly if you equate with this point y, the section equation or section formula, then again you will get ratio of m1 by m2. See, both are same, they should be same. So this is very easy to find, and we have C example 7 is exactly same, only numbers are different. So here I have shown this one what I have said. Just go through it. 5. Find the ratio in which the line segment joining A and B is divided by the x-axis. Also find the coordinate of the point of division. So the x-axis is dividing this line from A to B, and we are asked to find the coordinate of that intersection point. So how do you do it? Again, you know that x-axis is x comma 0, y is 0, x-axis is this. So since y value is 0, I can equate this one with respect to 0, and I put this value of y. This is minus 5 and 5, I have put it here. And now I get, if I equate this with 0, I will get m1 is equal to m2. So what does it mean? That P is a midpoint between A and B. So what is the coordinate of that P? So I know it is x1 plus x2 divided by 2, comma y1 plus y2. That is minus, this is 1 minus 4 is minus 3 by 2, and minus 5 plus 5, that is minus 5 plus 5 will be 0 divided by 2, 0. So this is a coordinate of the point P. Okay, now 6. If A, B, C and D are vertices, here these values are not given, x and y. So we have to find the value of x and y, and they are the vertices of a parallelogram taken in order. That is, there are some cyclic A, B, C and D. We have to find what is this x and what is y. So it is very simple to find. So I know what is the midpoint of this from this to this. X plus 1 divided by 2, comma 6 plus 2 divided by 2. So I get for this one. And similarly for B and D, and both the point are same, so you can equate it. Here what I have done is here P of AC, this B is a subscript, this mistake here. So now I get this point also. Now I can equate, this is x, this quantity, since these 2 points are same, this P and this P are same, the middle point of AC and BD is same. So this is equal to this. So I can know x. So I can equate this and find x. And similarly, y also I can find here. 2 plus 6 is equal to. So I can find the y also. So if you equate it, you will get x is equal to 6 and y equal to 6. Now 7, find the coordinate of point A, where AB is the diameter of a circle. So you have to find this coordinate x comma y. This you have to find. And this is the diameter. So this is the center point. And the center point is given to you as 2 comma minus 3. And B is also coordinate given 1 and 4. So if this is a center point, again I use 1 plus x divided by 2 is equal to 2, and 4 plus y divided by 2 equal to minus 3, because it's a center point. So I use this, okay, for x plus 1 divided by 2 is equal to 2 means x is equal to 3. Okay, this is 2 into 2, 4, and this 1 goes. 4 minus 1 is 3. So this. So similarly here, so you can get the value of x and y. Okay, now 8, if A and B are, this is A and B respectively. These are the coordinates of A. This is the coordinate of B respectively. Find the coordinate P of xy such that AP is 3 by 7. AP is 3 by 7 of AB. So this means this is 7. So if this is 3, this has to be 4. So this distance is 3 by 7 of AB, and P lies on the line segment AB. Of course. So by substituting this m1 and m2 here and x1, x2, y1, y2 in this formula, you will get the coordinate x and y. So this will be x, this will be y. 9. Find the coordinates of points which divide the line segment joining A and B. This is the coordinate of A and this is the coordinate of B. This is A and B into 4 equal parts. That means AC equal to CD is equal to D is equal to EB. So I can find first the center point here. It is very easy to find the center point since A and B is given. So you can always say x1 plus x2 divided by 2 will be the x coordinate of D, and y1 plus y2 divided by 2 will be the y coordinate of D. So once you get this coordinate D, again you have this A and D, and C is the center point. You can find the center point of AD. And similarly, since D is known to you and B is known to you, you can find the center point of DB as E comma xy. So please do it. Here I have written D is the midpoint of AB, C is the midpoint of AD, and E is the midpoint. So this midpoint you can know x1 plus x2 by 2 comma y1 plus y2 by 2. So it's so simple it is. Find the area of a rhombus if its vertices are A, B, C, D. This is given. Taken in order, of course, in some cyclic order. So this is also very easy to find. So area of a rhombus is half product of its diagonal. So area of rhombus is half time AC. So you find the distance, length of AC and length of BD, or distance between these 2 points is a length actually. So half of AC into BD is the rhombus. So you just find out, substitute here, you will get the answer. And check it in the book, in the solution section. Now area of a triangle given you 3 coordinates A, B, C. So how do you find it? Suppose this A, this is B, this is C. These 3 coordinates are given, x1, y1, x2, y2. And xdy. It is very simple. You find the area of this whole region and subtract this region, so you get the area of the triangle. So how do you do it? You find the area of this trapezium, that is ABQP plus APRC, this trapezium, and minus BQRC. Okay, so how do you do it? I will show you. So area of a trapezoid, this is taken from class 9 lecture 7. Go through it. So area of a trapezium is given. Suppose you have, this is a B1 is a base and this is another base B2. Then we know that suppose this is a trapezium, I can take a mirror reflection, same thing, and I can join it and I can make it a parallelogram. So this area is half of this parallelogram. So what is the area of a parallelogram? A length of the base times the height. Okay. So base length is B1 plus B2. Here B1 plus B2 into height. So half of it will be the area of this one, because I have just flipped it. This is the area which is required. So area is half of B1 plus B2 into H. So here I have written area of a triangle is, so area of this trapezium. So go through it is very simple. Just you can pause but anyway, let me tell you. So this is half of BQ, this is your BQ, and plus AP, so like this and this, times this is the height QP, okay, this is the height. Similarly, area of this one is AP for this is half of AP times CR, and this is the height, okay, PR, and minus of, I said that this trapezium, that is half of BQ plus CR, here B1 plus B2, times the height. Height is QR, so I have written QR. So now all this I can write. What is BQ? This here I have written, just go through it. So this BQ is y2 minus, this is here y is 0. So y2 minus 0 is y2. And then this is y1. So this is the base y1 minus 0 is y1. And then this is the height. Okay, this is your x1 minus x2. This is the height. This is a QP. So similarly for this also you see it and you get this formula. So this is the formula for triangle ABC given you coordinate of x1, y1, x2, y2, x3, y3. So you write in this way, you get the area of triangle ABC for given 3 coordinates. And this is very easy to remember, that area of triangle ABC for given 3 coordinates is half of x1, y2 minus y3. See, this is cyclic. Then x2, then after 2 it comes 3, so y3 minus y1, this is, and x3, then y1 minus y2. So 1, 2 and 3 are cyclic. So this is very easy to remember. Okay, x1, then x2, then x3 you remember. Then from x1 is followed by y2 minus y3, x2 is followed by y3 minus y1. So this you have to remember. Or you have to derive quickly, as I have explained it here. Example 11, find the area of a triangle whose vertices are this point A, B and C. So this is your x1, y1, x2, y2, x3, y3. Please substitute these values here. So you will get the area of triangle ABC. So x1 is here 1, then y2 is, this is y2, is 6, y3, this is minus 5, this is y3, minus of minus 5 become plus. Okay, so 6 plus 5 times 1. So this is where you do it and you will get the area of a triangle ABC. So here I have shown here, it is 24 square unit. This is very simple, just very trivial, just substitute x1, y1, x2, y2, x3, y3 here. So similarly find the area of a triangle formed by point. Again same thing, you just substitute x1, y1, x2, y2, x3, y3 here. So I am repeating it so that you will know how to do it. So here interesting thing is that you get an answer -2. Can you have area -2? So since area is a measure which cannot be negative, we will take the numerical value of -2. That is 2. Therefore, the area of triangle is 2 square. So -2 doesn't have any meaning. So area we will take as 2. Think about it, why it should be. Example 13. Find the area of a triangle formed by points. This is P, Q and R. So again it is very simple. So you get area of a triangle is 0. I have just substitute here x1, y1, then x2, y2 in this formula. And you get area equal to 0. So can we have a triangle of area 0 square unit? No. So that means they are collinear. So if it is all line in a straight line, so area of a straight line, you should have base into height, so there is no thickness, so line can be very thin, so area is almost 0. Okay, so what does this mean? If the area of a triangle is 0 square unit, then the vertices will be collinear, what I have said. Example 14, find the value of k if the point A, B and C are collinear. So that means area of a triangle has to be 0 if it is collinear. So you find the area of a triangle, equate it to 0, and from there you find the value of k. Okay, here I have shown area for triangle x1, y1, x2, y2. You substitute it, then you get this. So if you equate this to 0 because it is collinear, then you will get this is equal to 0, means this quantity means k has to be 0. Okay. Example 15. If A, B, C and D are the vertices of quadrilateral, find the area for quadrilateral ABCD. So you divide into triangles, okay, ABCD. So you draw a diagonal. By joining B to D, forming a diagonal, you will get two triangles, ABD and BCD. So you find the area of this triangle and the area of this triangle, that will give you the area for quadrilateral. Exercise 7.3. Find the area for triangle whose vertices are 1 and 2. So again use this formula. I am not going to, they have repeated many times the same thing again and again in your textbook. So in each of the following, find the value of k for which points are collinear. That means you find the area of a triangle, equate it to 0 and find k as what you have done here. So similarly this one also as we have done it here. So here I have written area of a triangle equal to 0 for 3 collinear points. So area you equate to 0 and find the value of k. Third, find the area of a triangle formed by joining the midpoint of the sides of the triangle whose vertices are A, B and C. So midpoint of A and B, B and C, and A and C, you locate it and draw another triangle from each of the midpoint, and you will have a smaller triangle. So how do you get the midpoint? x1 plus x2 by 2, then y1 plus y2 by 2. That is for AB. Similarly for BC and similarly for AC, you find the point. And once you have those midpoint, say AB midpoint, BC midpoint, and AC midpoint. You label it, and then you find again. You can find the area of the triangle, of the small triangle, and then you find the ratio. Means you divide the area of the bigger triangle by smaller triangle. You can know by how much factor it is. The big triangle is bigger than the small, or small triangle by big triangle means how much time the small triangle is smaller than the big. So what they have asked, find the ratio of this area to the area of the given triangle. So this is a given triangle. So ratio of the small triangle to the big triangles. Okay. So here I have said hint, find midpoint of this and find its area and take ratio. This is easy to do it. Now 4, find the area for quadrilateral vertices taken in order are A, B, C and D are given there. So this is very similar to this. So how do you find the area for quadrilateral? You do make it into 2 triangles and find the area of this triangle and this triangle, ABC and ADC, and add it. So that will give you the area of a quadrilateral. 5th, a median of a triangle divides it into 2 triangles of equal area. So what is median? Median is a line which you draw from one vertex to the base and it divides the triangle into 2 equal areas. So please go through my class 9 lecture note where we have defined what a median is. So see class 9 lecture. Verify this result for triangle ABC whose vertices are. So you draw median. Okay. So one of the median from one vertex to the middle point of the opposite base, okay, opposite side. So here I have said median point is, say D is half the base. So if you draw from one vertex to this base, you will get a median. So verify this result. So you will have triangle, say ABD and ADC, you will have it. So this is a D is somewhere in middle. Okay. So you just go through this and I'm sure you will be able to do it. So thank you and see you in next lecture.